Hey everybody, welcome to our second of the PC Perspective mailbag videos that we're doing today. Just me again. I went through the questions that people left on our first mailbag video, the comments, and found questions there and selected a handful of them, and we'll do the same thing again next week. So if you watch this video, you like it, you want to have a question or you have a topic you want covered, it could be about technology, it could be about the business side, it could be about future tech, past tech, anything you want. Leave a comment. People upvote good comments. I kind of scroll through all of them anyway and pick out the ones that I like that I know I can answer in a reasonable time frame, and we go from there. So let's go ahead and get to it. Our first question is going to come in from Louis King, excuse me. With the upcoming release of AMD's Threadripper having 4 dies located near the edges instead of the center, what method of applying thermal compound to the heat spreader? And I assume he means which method is best. There'll be some interesting science that comes in along this line, because the die are going to be, excuse me while this bug goes away from me, centered on the heat spreader, but there is a heat spreader anyway that's going to help kind of, as the name implies, spread the heat across the entirety of the package of the device. Now what will be interesting to see is how the water cooling, the self-contained water cooling plates, like those cold plates, make contact with the Threadripper processor, because I can tell you for certain that the Threadripper heat spreader is larger than the surface area of the coolers, at least the current generation that's out there in shipping that can be modified to work with it. My guess is, based on some stuff I've been talking with the AMD side, it's going to be as simple as a 5-dot pattern of thermal paste kind of on the center of it, spread out a little bit to look like the 5 side of a die, and that's probably going to be good enough. I don't think you'll need more thermal paste because it's a larger surface area. You will be covering the entirety of your water block, but I don't think it's going to be overly complicated either direction. Next question comes in from Kyle Texter. Would we consider selling PC Perspective t-shirts? We've never sold t-shirts. Excuse me. We've never sold t-shirts before, but we have given them away a couple of times. When we did our Indiegogo campaign, we had PCPer Live t-shirts made up. Honestly, the answer to that is somewhat tangentially related to the number of Patreon subscribers we have. We have just over 400 patrons, which is awesome, right? We have the following is doing great things there, and the money that they contribute to us allows us to do things like this video. I can dedicate a couple of hours a week to go through questions, generate questions, set up the video, record it all, and set it up for you. But that also kind of tells us that's the number of people, kind of the maximum number of people that are willing to spend money for the product we create, whether that be content or a t-shirt or whatever. So that's kind of what I feel like is our upper limit of sales. And truth be told, you know, if 50 people of those 400 are willing to buy t-shirts, it's kind of a lot of effort to generate a design, commission a design, find a t-shirt that's not a piece of garbage that I would wear, that I'd be proud to sell, and actually charge people money for it. And how much money would that be? Would that be $20? Would it be $30? You know, how much of it is, hey, you know, here's the cost of the t-shirt versus here's the cost of the t-shirt and some, you know, income for us. If that patron number were higher, say we're 1,000, and maybe now we're talking about 250 or 300 people that might buy t-shirts, it's a more interesting discussion. It's something we've heard, you know, Kyle, you're not the first person to ask this. If there's anybody that watches this video that maybe has an idea for a design for a t-shirt, I'm open to it for certain. Next question, Trolling for Dollars asks, do you think NVMe drives are worth the price delta over SATA 3 in tasks like 3D rendering, large Excel spreadsheets, 7-zip, and or VLC workloads? That's an interesting question. NVMe drives are significantly faster, they have lower latency, they have much higher bandwidth. I would say your workload is going to be a big determining factor, and whether or not you notice a difference going from a SATA 3 SSD, like a high-performance SATA 3 SSD, like a Samsung 850 or whatever, to like a Samsung 960. So 3D rendering, depending on the size of the data set you're using, could see an advantage, but I think that's more going to be compute limited, either on the CPU or GPU. Large Excel spreadsheets, probably not. That's going to be something that's going to reside in memory. What you will see advantages are in loading the large Excel spreadsheet from your NVMe SSD into memory. 7-zip could be a big advantage. If you're zipping up things on the NVMe SSD, the write speed, and in particular the small file write speed, might impact performance enough to warrant the cost difference. I think we can all agree that the NVMe prices are higher than they should be relative to SATA, but that's really just because competition has been minimal. There is a new Toshiba/OCZ drive coming out NVMe that is apparently very high performance, close to 960 level, and hopefully that will help drive prices down if it can come out a little bit lower as well. Sean Wilson asks a large question. Thanks for finally doing this. In all seriousness, I would love for you or Josh to explain IPC. When we get better IPC, is that because our clocks were underperforming, or are we somehow able to squeeze more than one calculation into one clock? You're not completely misunderstanding, but there is just some there's some difficulty in the answer, right? So IPC is instructions per clock, and it is a measure on average of how many instructions can be computed by a processor with each clock. And the way I'm trying to think of an easy way to describe this in just a 30 to 60 second window, a processor has pipeline stages, and in each of those stages, data exists in a moment in time. As the clock shifts to the next clock tick, the data moves down the pipeline. Sometimes it does, and sometimes it can stall there if there's a wait. It's waiting for memory or something like that. And there's all kinds of things that can happen, right? You've got instruction decode through the actual compute, through the ALUs, the floating point, the integer processing, to writing back to memory. There's a ton of stuff that occurs in the determination of how long an instruction takes to complete. It's not just a tick and thus an instruction is done. The instruction has to be read, has to be decoded, memory has to be fetched to access it, math has to be done on it, then it has to be written out, right? So there's lots of ways to improve IPC, but that being said, IPC has improved slowly because it's been a problem that has been optimized and optimized and optimized by Intel and AMD and others, and x86 and other out-of-order architecture designs for a long time. So it's not that anything was underperforming or overperforming before. It's just that they found ways to improve. AMD added a micro-op cache, for example, to the Zen architecture for the first time, and that basically allows them to decompress instruction code quicker, getting it into the compute pipeline a little bit faster, and thus improving the average IPC of the system. That's not a very good explanation, but it is very high level, and maybe we have Josh kind of come back with another option or their answer, and we can keep him talking less, keep him shorter on time. Camhen1, where do you see online written reviews going compared to, say, video reviews like Nice Tech Tips? Love PCPer, by the way. Thank you. From a business standpoint, it's been a very interesting transition as the emphasis on video increasing. I mean, look at this. We're doing this video right here. We're trying to create content for this particular audience that absorbs content in this way, and that finds it better than just doing text reviews. The problem is, in general, not always, but in general, video reviews have to be lighter on detail and explanation, because the attention span for video is, in general, shorter than somebody who's willing to read a written review. So if you see a review of us doing, like when we do our review of Threadripper, we'll have a video and we'll have a written review. The written review will have significantly more details in it, more analysis, deeper dive into some of the tech. And it's not because we don't want to explain that to our video audience. It's more that the video audience is a different type of person. I do worry that companies like AMD, on the Radeon side and on the Ryzen side, and Corsair and Lenovo and Dell and these guys that are basically investing completely in YouTube videos or video style reviews of their content, rather than going to the more in-depth analysis that you find in, not just us, but in Non-Tech and Tom's Hardware and those guys as well. Could do a disservice to the community in the long run, because the number of people like me who can stick through it, pay bills, pay employees, is going to shrink, and we'll just have less access to good data. And no matter how good I am, or a non-tech is, or tech report is, or whatever it's going to be, no one outlet can cover everything really well, and you need people to check each other. And if we see a decrease in that, I think that's going to be a negative, I guess I would say. Next question, Justin Denotter. Can we have a tour of the office, what it looks like outside, network setup, workstation specs, soundboards, etc.? We haven't really done that since we moved into this office, the old church building, if you will, because it's really never been set up in a way that I feel comfortable or proud of what it's become. Now, that being said, not that I'm not proud of what we're able to do. It's just things are unorganized. We still have cables that are kind of taped down across the floor, with the intent of running them through ceilings and through walls. Whether or not we will is a different question, as everybody in the office will attend to. We also have a lot of empty space. We have things to look at, but I think this is worth doing. We may do a handheld cam video walkthrough of things once we get a little bit more organized. We don't really have, and I think after the next week or two, we won't have any more product in here that is very, very strictly off limits. Nobody wants to see an office tour if half the workstations are covered in tarps or blankets or something, because you can't see them. Joshua French, is the tech reviewer segment of journalism too saturated, or is there room for a few more newcomers? Interestingly, I think my answer to this is both. There are a ton of people out there doing tech journalism, if you will, and it ranges from us to YouTube only guys, to even the coverage of technology and silicon and processors and GPUs at The Verge. Right, there's a huge range of what they're covering, how detailed they cover it, and accuracy of coverage, obviously. That being said, there's always room for new guys to do it, as long as they're doing it well. There's been a trend recently of people who just kind of come in, and if you say things that are very exaggerated, or you say things that are very inflammatory, you're going to get a lot of attention. And if you say it to the right audiences, at the right subreddits and all this stuff, you're going to get a lot of subscribers. And that's the kind of stuff that it bothers me, because I think it does a disservice to the entirety of the community. Somebody who just comes in, reads everybody else's content, and then says that everybody else is an idiot except them, really doesn't add anything to the discussion, right? If you think somebody's doing something wrong, or they're missing data, or they're misinterpreting it, then do your own testing. Now, I understand that we have access to resources that some people don't, but everybody's got to start somewhere. When you're building a new system, if you want to test Ryzen out, do it. Boom. Now you have your capability to test memory performance and core-to-core latency and CCX scheduling and all the other stuff that you want input on. So that's kind of an interesting answer, I guess, for that. Peter Jansen, if you have the required qualities to write good articles about technology, but you don't have a background in journalism, how can you get a shot at becoming a tech or science journalist? The answer to this is practice. Just write. Start a blog on Squarespace or whatever, or some free service, and just write. Even if you have no audience, even if you have nobody to pay attention to what you're writing, it's only going to get better with practice. I didn't go to school for journalism. I didn't should not have ate that bag of peanuts before this. I did not study English. I was not an English major or whatever. I was a computer science major that kind of almost knows how to write. And I just do it a lot. And, I get to a point where I could feel like I'm getting my message across to the right people. Once you start, and you need to have writing not only to practice, but then if you go to, say, email somebody like me or another website and say, hey, I want to write about computers and technology for you, you have a catalog of stuff you can point to. So here's some of the stuff I've done. Not that I can still improve, but here's my work and here's how I've been progressing. Doom M4, I don't know. I'm building a system with an M.2 NVMe drive for the first time. Is a heatsink necessary? If I was mistaken, will it reduce normal SSD speeds when it throttles from heat? And he was planning on going to Corsair Force MP500. The interesting answer to this is no, you don't want a heatsink on your M.2 drive in general. The M.2, actually, the M.2 SSD controller can have a heatsink just fine, and that may improve performance if it keeps it from throttling to some degree. However, Alan will be proud that we can discuss this now. The NAND memory itself, the NAND flash, runs better when it's hot, and it's going to run for a longer period of time if it's hot. So that's actually a reason to not put a heatsink on the actual memory itself. You can put one on the controller, but not on the memory is my recommendation. And I think in general, it's probably not necessary. Drocogen666 would love to see further testing regarding Ryzen and memory speed latency since the last AGISA update. When does diminished returns kick into performance gains for higher spec memory? I know people seem to be hitting stability barriers around 3466 and 3600. Yeah, and even AMD, when they kind of push Ryzen memory performance and updates there, they're kind of stopping at 3200. That's where they're peaking at right now. I think that's where the memory controller starts to have some problems. The answer is soon we'll have some more testing on, especially as we get into Threadripper. We're going to have more, a larger array of things to compare and see what the differences are going to be. But yes, I would say I personally have not kept up with the AGISA updates and their impact on overall system performance. And I also need to keep better track of the memory costs, right? If DDR4 3200 is consistently coming down in price, becoming closer to 2400, 2666, etc., then it makes more sense to use those in our test beds and our benchmarks and in our recommendations. Josh Russell wants to know, not sure I ever heard the answer to this, why or how is Optane so much better than just plain old hybrid drives, excluding the fact that it's not compatible with previous CPUs? Or why have I read that hybrid drives really haven't been so great to the point where I'm not sure it's even worth getting one over the normal hard drive? I assume by hybrid drives you're talking about those that have maybe 8 or 16 gigs of cache, of SSD, NAND cache on them. The reason Optane's better is because it's a faster memory technology, and it's significantly faster than Flash in latency. But it's also the algorithms of caching, right? Intel has done a very good job of working a driver in through Windows that is intelligent about what it caches when and for how long. That's basically the summation of why it is. Hybrid drives from Western Digital and the likes and Seagate haven't really been updated. It all is handled on firmware, so there's not as much logic that goes into it on the Windows side. They still help, but Optane's just better. It's just better at that in our testing. Let's see if we can get a couple of more here. Bill Foster, I'd like to hear your recommendation on the best parts and benchmarks on things a 3D production machine rendering with Maya and Houdini. He's more of a creator of 3D and video producer than a gamer. The easy answer for this is SpecView Perf. If you look at our professional reviews when we did the RX Vega, or not the RX, when we did the Vega Frontier Edition review, we looked at SpecView Perf. That is I think there's a Maya workload in that will give you some idea. In general, faster GPU is going to be faster at rendering in software like Maya or Houdini. But I would, the best answer is to find workloads that are close to what you're doing, and maybe solicit me or others or people who are doing professional graphics card reviews to use that type of workload. Although I do think SpecView Perf and Spec APC are the right places to start looking if you're going to look for reviews that are covering the specific workloads that make sense for your builds. Nconfia asks, would you cross over either you or the office PCs to Ryzen? The office PCs to Ryzen. Also, how did you first meet all the employees at PCPer? Yes, I'm actually running an old system, the one I'm recording this on, that needs to be updated. And I'm very likely going to pick either just like a Ryzen 7 1800X or maybe go with a 12 or 16 core Threadripper to update the system. Although that may be a little bit overkill for the type of production I do and office work that I do. But yeah, I actually have no reason to not use a Ryzen processor at this point. I think it might be good for us to do a little bit more of that across the board. It's just been for however many years we've had this homogeneous Intel ecosystem in our systems here. As for how did I meet all the employees at PCPer? Let's see if I can go through this pretty quick. Josh, I've known for a while, but I convinced him to come work at PC Perspective when we were at an AMD event in Tahoe. where he talked about, how he ran the website, but it was really hard for him because he didn't really make any money on it. And I asked him how much he was making, and I said, I'll match that and increase it by some amount if you come do this exact same work for me. And that's pretty much how that got started. But Josh ran a website called Pinstar Sys for a long time. He was kind of doing the reviews game for a while. He was just as verbose then as he is now. Alan worked in the Navy and contacted me about a problem he saw on an Intel X25M SSD that I was able to replicate for him, and then wrote a story for me about the problem, and it got Intel's attention. And then after he retired from the Navy, moved up here to Kentucky to work for me here. Ken was an intern. That he was a junior in high school looking for an internship for a program he was in. And he started out just editing the podcast and then turned to editing video, and then is now kind of the jack of all trades here of setting up systems and running benchmarks and figuring out what direction we're going to take in terms of what products are interesting. And he keeps track of the Reddit communities for me to see what people are talking about and what we need to pay attention to. Man, Jeremy is purely on the forums that I met. Jeremy Lee lives in the Cincinnati area, but I think I met him on the forums as well. Scott and Tim both emailed me asking for news positions when we were looking to hire at that point. Sebastian was a commenter and somebody hung out in the chat room for a while before he started writing for us. I feel like I'm leaving out some lists here. Maury, I had known, he used to write for HardOCP, had some personal issues, left and wanted to come back and write again, but they didn't have a position, so now he does motherboards for us. And if I'm forgetting somebody, leave it in the comments, and I will be reminded and embarrassed and tell you about how I met them. All right, one last question. Sorry, this one's gone long. Why have AMD and Intel not targeted single-threaded performance this generation? The 7700K was one of Intel's best-selling CPUs last gen. As someone who values single-threaded performance the most for games, but is also interested in a core count over 4 for productivity, what next-gen processor should someone like me choose? The answer, I think I already answered this. IPC is really hard to do. It's been super optimized, especially for Intel. The reason AMD was able to get a huge 40-something% increase in IPC with Zen is because they were so far behind Intel previously, and there was just a lot of room. They could look at what Intel had done and say, okay, look, there's no reason we can't make the same type of strides up to that performance level. So it's not that Intel and AMD don't want to improve IPC. It's that it's just really difficult, and you get into when you get into architectural adjustments to improve it, you're talking about cache sizes, which are expensive, take up a lot of die space. You're talking about branch prediction, which is, again, you're spending a lot of engineering hours and a lot of time on product that may make, a 0.1% difference. There's a lot that goes into it. In terms of what you should be looking for in the next gen, I think after Threadripper comes out and after Skylake X 16 and 18 core parts come out, you're going to have a better idea of what the landscape looks like. I think Ryzen will still look really good, and I think Threadripper is going to look really good compared to Skylake X in terms of cost per dollar. Single-threaded performance Intel is going to maintain for at least the foreseeable future, but there's a point where you get like good enough single-threaded performance where the multi-threaded advantages you get on one CPU over the other might be worth making your decision based on that. So that is going to be it, everybody. That's the second mailbag, longer than the first, unfortunately, over almost 24 minutes now. So I apologize for that. I wanted to keep these a little bit shorter and more direct. Again, if you have questions, please leave them in the comments of this video. I will go through them sometime next week, and we'll do another one of these exactly then. If you guys are, I know people are interested in what's going on in the secrets behind here. First of all, yes, we still have the pictures hanging out behind here. This system right here is running super secret hardware. That one has Vega on it, Vega Frontier Edition. This one has super secret hardware on it, and that stack of hardware is super secret as well. That's an Aorus 1070 external graphics box, but the other stuff behind it is super secret. I can't tell you for at least another week or two. So sorry, I got to move stuff out of the way when we do this. So like I said, thank you everybody for joining us, or joining me. And if you like it, let me know. If you don't, I guess let me know too. But otherwise, leave me your questions. Thanks, guys. See you next time.